Welcome everyone. Today's session is Introduction to Hill Cipher and its C implementation. The Hill Cipher is a polygraphic substitution cipher developed by Lester S. Hills in the year 1929. It encrypts data by using linear algebra principles, making it one of the earliest ciphers based on mathematics. This cipher encrypts blocks of text by using matrix multiplication with a predefined key matrix, which makes it stronger than many substitution ciphers. The encryption formula for the Hill cipher is C is equal to E of k comma p, which is equal to P into k mod 26, where P is the plain text, K is the key matrix, and C is the resulting cipher text vector. For decryption, we use the inverse of the key matrix represented as P is equal to D of k comma C, which is equal to C into k inverse mod 26, where we are taking P into k inverse mod 26. So this is about the encryption and decryption formulas. Let's go through the steps involved in implementing the Hill cipher in C. First, we define the key matrix, typically a 2 by 2 or 3 by 3 matrix for encrypting each text block. Next, we take a plain text input, convert it into numerical values, and split it into blocks. We then perform matrix multiplication for each block to encrypt. Then we are applying the modulo operation. We will take modulo 26 for each resulting element. Then we will calculate the inverse matrix for decryption. At last, we will convert integers back to letters. So these are the steps in C programming for Hill cipher. Let us take the C implementation of Hill cipher. This C program implements the Hill cipher, a matrix-based encryption technique specifically for a 2 by 2 key matrix. Here is a breakdown of the program and its function. This program encrypts and decrypts text using 2 by 2 key matrix. It converts the text into numbers, P is equal to 1, and so on, Z is equal to 25. This performs matrix operations, multiplication and inversion, and then converts numbers back to text. Here we are defining the constants and macros. This defines matrix size as 2 by 2, making the cipher compatible with 2-letter blocks of text. This is the function which finds the modular inverse of an integer A modulo m, which is necessary for calculating the inverse of key matrix. This function computes the determinant of 2 by 2 matrix, which is used to calculate inverse of the matrix. This function calculates the inverse of the 2 by 2 key matrix. If the determinant's modular inverse doesn't exist, the function displays an error, as this would make decryption impossible. Next, we will go for perform the matrix multiplication and for encryption and decryption. This performs matrix vector multiplication used in both encryption and decryption to multiply text vector blocks by the key or inverse of the key matrix. These are the text function conversions we are using. Convert text into numbers, which can convert letters A to Z to numbers 0 to 5. Void text to numbers, this can convert numbers to text, numbers 0 to 25 back to letters A to Z. Void numbers to text, this can convert numbers to back to letters. And this is the encryption function we are using. We can encrypt the letters by processing each 2-character block. It can convert text into numeric form, multiplies it by the matrix, and converts the resulting numbers back to letters. Next, we will go here the decryption function, which decrypts the ciphertext by using the inverse key matrix in place of the key matrix to recover the original text. Let's go to the main function here. This is the main function where the user prompts to enter a 2 by 2 integer key matrix whose values are between 0 to 25. Then user prompts to enter the plain text with uppercase letters. There is no spaces in this one, and the length of the plain text should be the multiple of 2. And to encrypt, we can call the encrypt function and displays the ciphertext. Then we can calculate here and finds the inverse of the key matrix, which is used for decryption. We can call the decrypt function and display the decrypted text to verify the encryption. So with this, we will conclude our C program. Let's run the program here. Let us take the 2 by 2 key matrix here. We are taking the numbers. The 2 by 2 matrix size, we are taking 3325. Let us take the plain case of all upper cases here. I am taking hello. If you observe here, plain text length should be a multiple of 2. But here there is no multiple of 2 now. So it gives the suggestion to us to take the plain text length with a multiple of 2. Let us run once again the program. So the key matrix I am taking 3325. Then I am taking my plain text now, HELLOALL, hello all. So this is my plain text. The encrypted text is HIOZQCOZ and the decrypted text is hello all. This is based on Hill cipher. So the formula here we are using is equal to C is equal to K into P mod 26, where P is the plain text, C is the ciphertext vector, and K is the key matrix. For decryption, we are using P is equal to K inverse into C mod 6. So this is for encryption and decryption based on the Hill cipher. The advantages and disadvantages of the Hill cipher is it uses the use of matrix multiplication, which makes it more secure against frequency analysis and improves encryption strength. However, there are challenges. The Hill cipher requires the use of invertible matrices, which limits the choice of the key matrices. It's also vulnerable to attacks if multiple plain text to ciphertext pairs are known. Overall, it's an effective cipher for the secure block encryption, but can be complex to implement the decrypt without the correct key. So with this, we will conclude our session.